In this video, I'm going to be talking about Kirchhoff's rules, his junction rule and his loop rule, both of which we're going to need in order to solve for the currents, the voltage drops, and the power through any which one of these resistors. So the way I'm going to start is I did draw a couple things in already, and you just want to make sure that you label your different points and currents with different subscripts so you know which part you're focusing on and which variable you're looking at any point during this problem solving process. So when you're taking a look at a multi-loop circuit, you can't very accurately predict which way the current is going to flow. So I just guess that this one is going to go clockwise and this one is going to go counterclockwise. If you guess differently, that is totally fine, and I'll tell you why later on in the video. Once we completely finish solving this problem, you'll still be able to get the correct answer whichever way you guess. So I called this I1 for current 1, I2 for current 2, and then I3 for current 3. I1 is representing this part of the loop on the bottom, on the side, and on the top. The part that is joining these two loops, I call it I2 because I know that something is happening a little differently with the flow of the charges in the middle there because it's connecting our two loops, and I3, which is this portion on the bottom, side, and on the top. Okay, so I'm going to label my two junctions. I'm going to call this one J1 and this one J2. And the junction rule says the sum of the currents going in to the junction is equal to the sum of the currents going out of the junction. So we have I1 going into junction 1 and I3 going into junction 1. So I'm going to go ahead and write I1 plus I3, and that equals I2. So I2 is the only current that is flowing out of this particular junction. Okay, does it matter if you pick junction 1 or junction 2? It really doesn't matter. If you take a look at junction 2, we would say that we have I2 going into it, and then flowing out of junction 2, we have I1 and then I3. So that would equal I1 plus I3. And as you can see, if you take a look at the two formulas that I set up, the two equations that I set up, they're just the same in a different order. So we're going to go ahead and use that a little bit later on in our problem solving process. All right, now for the loop rule, the loop rule is that so let me go ahead and label that actually. So here is our junction rule. And then let's go ahead and do our loop rule over here. So there may be voltage increases and there may be voltage decreases, but overall the delta V, the change in voltage for any particular loop, is always going to be 0 volts. Okay, so what I'm going to do is I'm going to follow my circuit over here on the left. I'm going to follow my first loop around. Okay, so I'm just going to start here right next to the power source. And if I start there, and I'll just go ahead and label this 1, because this one is my loop number 1. And as I go through the set of batteries or this power source, it is going to step up my voltage 25 volts. Okay, and then as I go around this loop, it looks like I'm going to pass through this 20 ohm resistor, and my voltage is always going to be the current times the resistance. Okay, so the rule is if you are flowing in the direction of the current, it's going to be a voltage drop. So if you're flowing in the direction of the current, it's going to be a voltage drop, and then vice versa. If you're flowing against the current, then it's going to be a step up in the voltage. So I'm going to put minus, and then I times R. That I is the I2, and that R is 20 ohms. Okay, and then we can set that equal to 0 volts based on our loop rule. And then for our second loop, I'll just call this loop number 3 because I called it I3 earlier. So for loop number 3, we're going to start right here. by the power source again, and then we are going to work our way around counterclockwise for this one. So I'm going to pass through my set of batteries or my power source there, and it's going to step me up 30 volts. And then it's going to pass through the 5 ohm resistor. Again, that's with the current. Okay, I could have chosen to go the opposite direction, but I chose to go counterclockwise. So it's with the current, so it's going to be a voltage drop. So minus I, so this I is I3, and the R is the 5 ohm resistor. Okay, and then it's going to go through my 10 ohm resistor. Again, it's still flowing with the direction of the current, and that's still my I3. So minus I3 times 10 ohms. And then same thing I did with the other loop. I have to go through the 20 ohm resistor to circle back over here. So I'm still going in the direction of the current. So minus I2 times 20 ohms. Okay, and then again, I kind of ran out of room there, but all of that equals 0 volts. Okay, so what I need to do is I need to use a system of equations, and then I can go ahead and solve for my I1, I2, and I3. And if I get a positive number, then I know that my guesses were right and that my current is correct. And then if I get a negative current, that means that I accidentally drew my current in the wrong direction, and I just want to flip the arrow in the exact opposite direction of what I originally drew. So what I can do is I can go ahead and take a look at my first formula over here, and I decided to go to my first one because there's only one unknown variable, which is my I2. So I'm going to take my equation number 1 and I'm going to rewrite it slightly. I'm going to drop the units for now just to simplify the look of it. So it's 25 minus, and then I2 times 20 ohms. I'm going to put the 20 as my coefficient in front of it. Okay, and then I can subtract 25 from both sides. Divide both sides by 20, and then my negative signs are going to drop off. That means I2 equals 25 over 20, which comes out to 1.25 amps. So what I can do is I can go ahead and take that 1.25 amps, and then I can plug it into my I2 into my second formula, which I call number 3 because it's loop number 3. And let me rewrite this one, and I'll simplify the look of it. I'll call this 30 instead of 30 volts. Pull the 5 in front because I just like the look of that coefficient in front. So 5I3, and then minus, I do the same thing with this one, 10 I3, and then minus, and then I'll go ahead and do this quick calculation. My I2, remember, is 1.25. So 1.25, I can slide in right over here, multiply it by 20, and then that's going to give me 25. So I can go ahead and simplify a couple things, and that's going to make my problem solving process pretty easy from there. If you take 30 and then minus this 25, you have 5. And then I have minus 5I3 and then minus 10I3. And I can call that minus 15I3. And that is all equal to 0 because my total delta V for that loop is 0. So then I subtract 5 from both sides, and then this becomes negative 5. The negatives do drop out again, and then I divide both sides by 15. Okay, so my I3 comes out to 1/3. And then if I want my I1 is the one that I haven't gotten yet. That's where I'm going to slide over here and go back to my junction rule. And now I have my I2 and my I3. So what I can do is I can go ahead and plug in both of those values, and then it'll be pretty simple to solve for my I1. So I went ahead and plugged in my I2 of 1.25 amps. My I1 is my unknown. And then I took the 1/3 for my I3 and I approximated it and put it into decimal form, and I just called it 0.33A. So when I subtract 0.33 from both sides, then my I1 is going to come out to 0.92 amps. Okay. Now, it just so happens, and I actually wasn't sure this was going to happen, that all of my currents came out to be positive. Okay, now the rule is you're kind of guessing which direction they're going initially. You may be right, you may be wrong. And if you happen to be wrong, so say for example, um, my I1 happened to be negative, then that would mean that it's going in the exact opposite direction. Okay, so it's going in the exact opposite direction and be going counterclockwise. So same thing for I2. If the I2 came out negative, then that would be going in the exact opposite direction. So that would be upwards. Okay, so if you do have a negative sign with your answer, that's going to change the way in which you look at the circuit as far as the way that the current flows. So we didn't have that issue this time around, but it's a pretty easy fix if you do get that negative. So in the end, if you want to solve for some voltage drops and some power values, what you can do is you can go ahead and use your currents, because we know our currents flowing through any particular part of the circuit are right over here, I1, I2, and I3. So if we want to find an individual voltage drop, we can do I times R. And if we want a power output for any particular one of the resistors, we can go ahead and use power equals I times V after that. And then we can go ahead and solve for our power values as well. So I hope that was helpful in helping you understand Kirchhoff's junction rule and loop rule and how to use those in combination to find your currents, voltage drops, and your power outputs. Thank you very much for watching and listening.